All right, I jumped the shark and I accidentally hit the button before I hit recording. So this will say proceed to the meta-analyses. Now it just says view meta-analyses since I already clicked it, but it's the same. So once we click this, we'll get this blank screen because we haven't created any meta-analyses yet, and we can add a meta-analysis specification. This is where we choose our algorithm of choice. If you're used to ginger ale, you'll choose ALE. If you've used Nightmare, or if you're a fan of the Neurosynth original platform, you might use MKDA chi-squared or MKDA density. So these are all slightly different ways of drawing circles around coordinates, basically, to measure the overlap between other analyses and studies. We don't recommend you use kernel density analysis, since that one's been superseded by multi-kernel density analysis. So if you're using one of these, I would recommend using one of these and not this one. All right, we'll stick with MKDA density, and we'll close that up. You have options to specify, say, how far around the little circle or the coordinate do I want to draw this kernel or circle. So larger means it's more likely to overlap with other coordinates that are being reported. Smaller means you have to have more specificity for the coordinate reports to overlap. For most of these, you can just accept the defaults as they are. We can show advanced, and if you're familiar with Nightmare and using the Nightmare API, this is where you can put in unique arguments for Nightmare, specifically the MKDA density, the MKDA density extractor or transformer that's within Nightmare. With every transformation of coordinates into these maps, we apply a corrector. Optionally, we could say we're not going to use a corrector at all, but we do highly encourage you to use a corrector. Again, for first pass, you can use the defaults. When you want to step up your analysis game for publication, we do recommend using not false discovery rate corrector, but the family-wise error corrector. Since the family-wise error corrector is going to be, more robust to the non-parametric distribution of coordinates spatially across the brain. So this will be a more robust corrector than FDR, but it is a lot slower. So for getting a first pass analysis, you can definitely use FDR to get a sense of, does the brain look right? Does this map correspond to what I think it should look like? For the next stage, we select what analyses we want. So that's what those checkboxes were helping us with. We can say, I want to include only analyses, which one of the populations was selected as first episode, or I want to include all the analyses that were in the included column in that Boolean, because that's the one that we give to you by default. And you can look at the summary of all the analyses that you have selected down here. Hit next. We can give this a name, so you can MBAC meta-analysis, MKDA meta-analysis included. I mean, it does give the information that we want, but you can call it whatever you want. My first meta-analysis. And yeah, you can call it, you can give a description of what you would like. And this gives all the information of what you just specified. and 2 analyses that were not selected, so that's 59 out of 61, and we can say create meta-analysis specification. And that will lead us to this page, in which we have 2 options to run our meta-analysis. If you're a little bit more tech savvy and you have Docker installed on your computer, you can use this one and hit copy and then run it on your terminal. If you don't want to install anything on your machine, because once Docker is installed, it's nice, but it's such a pain to install. So you're like, not for me. We'll hit copy to copy this unique analysis run ID, and we'll open up a Google Colab notebook, which already has everything displayed in it. And we'll cover that in the next video. Yes, we'll cover that in the next video.